Hi everybody, welcome to a review in statistics. Just a reminder, in the description there's a timestamp for each problem. Right, let's start. First, we'll distinguish qualitative and quantitative variable. Qualitative is category, name, and quantitative something to do with the numbers. So this we talk about the temperature of the cups. So the temperature is a measure, so they have to do with the numbers. So it will be quantitative. Next, distinguish discrete and continuous. Discrete is something has finite or countable. So if we talk about only number like 0, 1, 2, even though this go indefinitely, it is countable. Or if we talk about some finite values, something only have the few values like 2, 3, 4, maybe 2.5, 3.5. Let's say if we have a set only have these values, that also considered to be discrete because they only have finite values. Alright, so if it is not discrete, it will be continuous. Alright, so we have two examples here. The weight of a player on a wrestling team, or the weight could be any number, even though it is listed sometimes just as a whole number, but in reality it could be any decimal place. So that could be continuous. Whereas the number of goals, for sure it is finite and only take a few values. It's countable, so it is discrete. Next, we have level of measurement of variable. So there are four of them: ordinal, interval, nominal, and ratio. Nominal is the lowest and ratio is the highest. Right. So when we get to the answer, we explain what is each one does. Right. So the musical instrument played by a music student. So a musical instrument, so that could be, let's say, violin, guitars, and so just category for once. And then also, even though this category we cannot rank them, they have I would say equally important, if you will. So something that have category and there's no order. So that is nominal. Next, the day of the month. Well, this is first of all, this have to do with numbers. So it's going to be interval or ratio. Now talk about the date. Let's say today is the 10th. 10 days later, that will be the 20th. We don't say 10 days later will be twice the day that we are today. But we can, there is the difference between, there are 10 days different, but we don't say that twice the days. And there's no day 0. So again, there's no ratio, so it cannot be ratio because they said the 20th day and the 10th day, they're not twice as much. So there's no ratio, there's no number 0, but there's number. And the subtraction, we can subtract them, like the 20th day is 10 days after the 10th day. So this deal with number. We can subtract, we can add or subtract, but there's no ratio. Right. Next, the official rank in the military. That would be the interval. I'm sorry. That would be ordinal. So an officer rank, let's say the lieutenant or general, something like that, is category or names. But there's ranking. So that is ordinal. And then we have the weight capacity of a backpack. So now, even though the weight, we actually mean the mass. So let's say if a backpack that weighs 2 pounds and the one that weighs 4 pounds, the one 4 pounds will be twice as heavy. So that makes sense. And if the weight equal to 0, we say that is weightless, which is good. So 0 has a meaning, ratio has a meaning, and it has to be a ratio again. This number, so it's ratio interval. But we check that, we see that ratio has meaning. Ratio and number 0 has meaning. And when that is the case, it's going to be ratio. Right. Next, we distinguish between observational study and experiment. Okay. So first, a medical researcher obtained a sample of adults suffering from diabetes, 42 people to a treatment group and 42 to a placebo group. The treatment group received medication. Okay, read the problem. Now the second problem, we all have the sample of 100 smoker and random sample of 100 non-smoker. After interview all 200 participants in the study, the researcher compared the rate of depression among the smoker versus the rate of non-smoker. So the difference of these two is that we have, the same thing, they have two groups. The difference is that here we have the treatment group. The treatment group will receive medication, and the other placebo group, of course, receive placebo, which is something like medication but has no effect at all. So in that case, this is experiment because we actually decide something do different on the two groups, whereas on the second research it's just an observation. So we just have two groups and we just ask questions. We don't ask them to take anything. So that's the difference between the two. Right. Right. Next, set of prompts will distinguish different type of sampling method. The idea of sampling is that to get a better representation of the whole population, the sample is good if it represents the population well. And the way we do that is stratify, systematic, simple, random, or cluster. Convenient will never be a good sample. Right, and look at the first problem. 35 majors, math majors, 34 music majors, and 65 history majors are randomly selected from each one. Bigger set. What sampling technique is used? Well, first of all, we have 35 maths from that much, 34 from 453, and 65 from that much. So pretty much we divide into groups and we select some of each group. So that is called stratify. Right. So stratify is we divide into group. Each group has some common characteristics like math majors, music major, and history major. And in Stratify, we're going to choose some random sample for each one. So that is Stratify. Next, every fifth arrow entering an airport is checked for extra security screening. So we see that so this is kind of the signal for saying that is going to be systematic. Next, at the local technical school, 5 auto repair classes are randomly selected and all of students from each class are interviewed. Alright, so here's the keyword is, so there are 5 classes and all are selected. So the difference between the cluster and Stratify is that we divide into a bunch of group. With cluster, unlike Stratify, we have to choose some for each group. This we choose some, but we choose the whole group. So that case is cluster, we choose the whole group. It means some whole groups, but not the whole thing, of course. So that is a cluster. Next, based on 9,000 response from 44,500 questionnaires sent to all the members, major medical association estimate that the annual salary was what sampling technique was used. Right. So this one is not very clear that but this is simple random, so it did not say how the 9,000 are selected from that, but it did not say you just pick out the first 9,000. That would be the convenient, would never be good. So in this case, it did not specify very well, but I will assume that 9,000 from that kind of a random. If it is random, that is good, and that's just a simple random. Right. Next, I'll provide the relative frequency 2000. So in this case, we construct the frequency distribution and relative frequency distribution. So pretty much we count. And then we have to just ask for their favorite color. So favorite. Right, first purple. 1, 2, 3. Frequency is just how many times it happened, how many times it occurred. And for purple, there are 3. Next, green, 1, 2, 3, and 4. And then blue, just going to circle 1, 2, 3, 4, 5. And then red, 1, 2, 3, 4, 5, 6, 7. And I will only have one yellow. Right, so that frequency, how many times each one occur. And now to find relative frequency, we just find how many of each one compared to the total. So the total will be 3, 4, 5, that's 12, 7, 19, 20. So the total is 20. And then we just say each one relatively to that total number. So 3 over 20, and it's at 2 nearest 1,000. So that will be 0.15%. 4 over 20, that 20%. 5 over 20, 25%. And 7 over 20, 35%, or 0.35. And 1 over 20, 0.05. And if we add all of this up, 40, 60, and 40, so that should be 100% or 1. Right. Next, we construct the frequency bar graph. So the bar graph, and next one will be the histogram. Bar graph and histogram are two different things, kind of same in the sense that they will have bars, but the different things is the bar graph is for categories and histogram for numbers. Right, and the bar graph is usually easy to graph than the histogram. Histogram, there will be no space in between, and the numbers have to be accounted for, and have to be we cannot interchange the column. This we can interchange the column easily. Right, so 1, 2, 3, 4, there are 4 of them. So 4, we just choose 4 column, and the column doesn't matter. Just say the column is this much, and we have some space, another column, another column, right? And then on the frequency, how many times that occurred? Up to 13. So let's say 5, 10, that's 15. All right. So first one is 13. Next one is 9. Next is 6. And then the last one is 2. So for the bar graph, we can interchange the column if we want to. there will be space in between, and then of course we have to label everything. So this is so slow down. Or to stop. Right, and he would have to have numbers, and of course would be just that, but and the graph should have the title. This is traffic offenses in a construction area, so we just say it. Yeah, so we just like that. Again, the bar graph, the bar has equally divided with the space in between, and the column you can interchange if you want to. Right, next, construct the frequency polygon for data. Right, so frequency polygon. So we are given a group data here. So we have to choose a number to represent each group for the frequency polygon. That is called the class midpoint, a number that represents the whole class here. So we call the class midpoint. So just pick a number in between here. And the number we pick is not number divided by this. Remember, number in between is the number in between consecutive lower class limit. So the way it works with the data is that, let's say if we have 135.5, it will be in the first group, in the first class. It will be 135.99999, it still be in the first class. So we always count from the lower and then up. So 135.01 to 139.9999999. Right. 135 to that. So in that case, we use the low class limit to find the midpoint. So between 135 and 140, I'm just going to do 1 here. Just add them. And then divide by 2. So that's 137.5. And then between these two classes, it's going to be 142.5. Between these two, 147.5. And these two, 152.5. And then 157.5. And you see it's increased by 5. So the next one will be 162.5, and the one before that 132.5. We do need that. Right. Next, frequency polygon, we just have 1 point. So first we have 6 will be where it is 137.5. So just play that by 1 dot. And then 142.5. That will be 4. 147.5. That will be 11. 152.5. That would be 15. And 157.5, that's 8. Right, 6, 4, 11, 15, and 8. Actually 15 is here. Okay. Now just connect consecutive dots. Right, but we're not done. In the frequency polygon, we have to connect that back to where it's 0. So 162.5, that will be 0. So we'll connect that to 0. And the one before that is 132.5. So yeah, so that is the frequency polygon. Just find the class midpoint, connect the point, and connect back to 0. Alright, next, I'll describe the shape of the distribution here. So, this one, most of the data on the left, so it's skewed to the right. So kind of backward like that. If it is like this, is skewed left, and symmetric is something it is like that. Uniform is where the data just kind of uniform, the same. Alright, so this one skew to the right, it's backward. Next, we construct the stem and leaf plot for this data. So for stem and leaf, we separate the last digit with everything above that. Everything be above that is going to be a stem. Everything on the right side, we just wrote the leaf. So here, the last digit will be the ones place, and the 10th place will be the stem. Right. The 1, 2, we just say this the stem, and it's the leaf. Right, we look at this, we see that there's a 58, so we'll write the 5 on the stem and then 8. Right? But of course we have to write that in order, and we do see there's a 15 there. Right, so that's gone. There's no 20, no 30, no 40. There's a 58. And there's a 50. Sorry. So that's why we mark like this. Right, good. Now onto the 60s. 66, 69. Right, that's it. Onto the 70, there are quite a few. 76, 77, 79. Now 80s, 87, 88, 89, 83, 88, 82, and the remaining are 90s, 98, 94, oh, I forgot the 85. That's right, we need to mark them off. So, and the 92, 98, 94, 90, and 96. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. No, 20. So it's good. Right. But the final result, we have to rearrange the leaf in increasing order as well. So to this. Right. So we have the stem and leaf. 15. There's no 20, 30, 40, 50. There's 0 and 8. These have to be in increasing order and should be lined up vertically. 6, there will be 66 and 69, 76, 77, 79, 80. Now this one have to increasing. Put them in increasing order. 2, 3, 5, 2, 3, 5. 7, 8, 8, 9. Right, and then for the 90s, increasing order as well. 0, 2, 4, 6, 8. Right, so that is the stem and leaf plot. Right, now we'll find some statistic for the sample. The repair cost of 5 cars which were crashed by a safety testing organization was followed. Find the mean. So the mean is pretty much the average. We just add all of them up, divide by how many we have. 100 plus 150 plus 200 plus 250 plus 150 divided by 5. So that's 170. And if we use proper sample, this is for the mean of a sample. Next, the commuting times. Oh, the timestamp. The commuting times in minutes of an employee for 10 consecutive days are listed as below. Find the median commute. So the median is the one in the middle. For that, we have to put this in an increasing order. Right, 67, 67, and 68. And then 71, 72, there will be 1, 2, 3, and 4. and then 73, 76. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so this have to be in increasing order. Or decreasing is fine as well, but usually random in increasing order. So when there is in order, we pick the one in the middle. Since there are 10 of them, there's no one single one in the middle. So we're going to take the average of the middle too. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is right here. And the symbol for median is that, or the capital M. But anyway, the middle of those is still 72. Right, next, the commuting times of 10 employees in minutes are listed below. So pretty much the same type problem. This time we find the mode. The mode is the one that occurs the most. The mean is average. The median is the one in the middle. In the middle. So once again, the mode is the one that occurs the most often. So when we look at this, we see which one occurs the most. There are 266. 67 there are 2. 70 there are 2. 67, 1, 2, and 3. So that one will occur the most often. So they'll occur 3 times. The other, there are only 266, 270, and so on. So the one occur the most often is the mode. Now, which measure of central tendency is more representative of the typical observation in the graph of the data that skew left? So unless it's symmetry, if the data skew one side or the other, or if there are a bunch of extreme values, we want the median will be better, because if let's say we have this data and we have something like 10,000, that will certainly will change the average by a lot. But if we take the mean, we will take the median, I'll just move a little bit. So if the data are not symmetry, or if the data has a bunch of extreme values, it would be better to choose the median. And the technical term for that is the median is more resistant to extreme values. So that's what we have. Right, next, compute the range for the set of the data. So the range is the highest values minus the lowest values. So it's straightforward. And here we only have 8 and 17. So the highest is 17, the lowest is 8. The difference is 9. So that will be the range. Pretty much just the highest minus the lowest. Right. Next. In a random sample of 10 employees at a local plant were asked to compute the distance they travel to work near 10 of a mile. Here is the data. So here is easy. We will calculate the range, which we just did similarly. But sample standard deviation and sample variance, this I prefer using the calculator for that. But first, let's do the range. Take the lowest, highest, subtract the lowest. The highest is 5.2, and the lowest is 0.8. 5.2 minus 0.8 is 4.4. So this is the range. Right. Now, we use a calculator to find the standard deviation and variance, this time for the sample. Right. Hit stat and enter. If there's something in the list already, highlight the list, hit clear, and then enter. It has to be clear. Right, now we just enter the number 1.1, 5.2, 3.6, 5, 4.8, 1.8, 2.2, 5.2, 1.5, and 0.8. Route check. 1.1, 5.2, 3.6, 5, 4.8, 1.8, 2.2, 5.2, 1. Right, so that is correct. I'll just hit second mode, back to home screen. Right, and then we hit stat again. This time go to calculate one variable statistic, hit enter, and the data from this one. If you want to change to something else, there are 6 available lists. Second, number 1 to 6 give us that, but we have the list 1 for it. We calculate. Right, so give you a bunch of information, give you the lowest and the highest and the median and quartiles and a lot. But this time we focus on the sample standard deviation. Right, there's 2, one with an S, one with the sigma. The sigma is the population, the S is the standard deviation. So first, the sample standard deviation is the S. And I'm going to write 1.823. And next, the question asks for the sample variance. Sample variance is going to be the square of the sample standard deviation. So we can just write this number, just copy that number, and we square. Or we can just use the exact numbers. It is under variables, statistics. We have that. All we need to do is square it. Right, so that is the sample variance. Remember, stat, one variable statistic, and this is the S for the sample. The sigma is for the population. Right, talk about population. That's what we have next. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just only enter all of this in. Right, stat. Edit. You can just clear the list, but on the test, if we don't really need to clear it, just go to the second one and enter. So later on we come back and we don't have to enter the numbers again. Right, let's check. Right, we're done quick. Now go stat, calculate one variable statistic. This time remember this sum from the second list. So I have to be second 2 for list 2. Right, let's calculate. This is the population standard deviation. Is the sigma 68.1. So that is the sigma is the population standard deviation. If we want the population variance, we're just going to square this. The variance is the square of the standard deviation. Right. Next, student receive the test score of 62, 83, and 91. The student term project score is 88, and homework score is 76. Each test is 20%, the final grade, and the term project is 25%, and the homework is 50%. What is the student mean score for the class? Well, that. Right, so it says that there's a bunch of categories. Let's just say it. Category pre-test score, so just say test 1, test 2, and test 3. And here's the grade. 62, 83, and 91. The project is 88. Homework $76. Each test is 20%, so we have the grade. Next, there's the weight. It is 20%. Alright, it's decimal. The homework grade is 15%, and the project is 25%. Right. So, what we do here, we can just multiply across and then add them. That will get us the answer. So, just multiply straight across and then add them. Right. Let's use calculator for this one as well. I will clear the two lists here. Highlight it, hit clear, and then enter. Never delete a list. Never highlight it and hit delete. That will be wrong. That take a lot of time to fix. 62, 83, 91, 88, and 76. Next one will be 0.2, 0.2, 0.2, 0.25, 0.15. Right, so we just multiply straight across. For that we just highlight L3 and we say we multiply list 1 times list 2. So we have 12.4, 16.6, 18.2, 22, and 11.4. Now if we add all of this up, we have the average. So pretty much we add everything in list 3. So there's a way to do that in the calculator as well. So second and stat, go to math, option number 5, and we sum everything in list 3. That's 80.6. That's one way to do that. Write out the grade. Now the important thing is we want the mean score, so we put the mean in the first, the grade in the first column. We don't put the weight in the first column. By first column, I mean in the calculator. Like the score will be in the first one, because we want the mean of those. Right. The weight will be on the second. If we do this by hand, so hit stat, one variable statistic. The list will be from this one. The frequency list will be list 2. And calculate. And we have 80.6. So that's another way to do that. Right, next. For the following data set, approximate the sample standard deviation of distance from work in Mars. So this is the sample standard deviation, and this is the data. Right. So before we actually do that, we have to find a number represent each class, and like we did earlier, this is called the class midpoint. So we find the midpoint, a number that represent each class. Right, so we write the class midpoint. Right, so class midpoint once again is not the average of this, the average of consecutive class limit. So in that case, if the distance is, let's say, 10.99, or I mean 11.99, will belong to the first class. So we count from 8 up to 12. Anything just below 12 will be in the first class. So 11.99 will be in the first class. So in that case, it makes sense to take the midpoint to be the average of consecutive lower class limit. So 8 and 12 will be 10, 12 and 16, that will be 14, 16 and 20, that will be 18, 20 and 24, that's 22, 22 and then 24 and the next one will be 26, because simply we increase by 4 every time. Right, so I have the class midpoint. So I will put this, usually when it's standard deviation, I prefer to just use a calculator here. Put that in list 1, the frequency in list 2. We won't be able to put the range of numbers into a list. And then we just find one variable statistic, look for the standard deviation. So pretty much that. I will clear the two lists here. Clear. Have to highlight the list. Clear. Clear. If you accidentally hit delete, it will go blank. We have to rename it. Okay, so don't hit delete. If we delete, we have to delete everything and rename everything. So that's kind of confusing. Right, so list 1, we're going to put the class midpoint 10, 14, 18, 22, 26. And then the frequency will be in the next one. Right, check the data. And then right? So quick, once again go to one variable statistic, stat, calculate one variable statistic, list 1 for the values, list 2 for the frequency, so that's good. Now calculate. If we look for the sample standard deviation, this is the S. The population will be the sigma. And if we want the variance, we're going to square the standard deviation. Right. Next, find the z-score for the values of 50 with the mean is 78 and standard deviation of 9. So the z-score, let's say this is for the population. So we're going to use the values minus the mean over standard deviation. So if it is the sample, we're going to use this sample for sample. It doesn't matter, but minus the mean divided by standard deviation. So what we do is we take 50, the values, minus the mean, and whatever that is, divide standard deviation of 9, negative 3.11. Right. Of course, you can put everything at once. Alpha y equal the values minus the mean over standard deviation. We can change to decimal. There, right. Next, the percentage measure that are above the 39 percentile is, of course, 39%. Right. 39 percentile. I'm sorry. 99 percentile will be the top 1%, but 39 percentile is where 39 below it and 71% above it. This one asks for above. Of course, if you do the math correctly, 100 minus 39 would be 61. Sorry about that. Right. So this is 39% below it, and 100. Subtract that, will be above it. Right. Right. Next, the weekly salary in dollars of 16 government workers are listed below. Find the 36th percentile. Right. So first, we're going to list all of this in increasing order. Right, so that on the 400, the 500, we have 1, 2, 3, and 4. This is the lowest. That's 7 of them. And now the 500 now, oh, the 519. Oh, shoot. I just have to put that here. Right. Now the 600. 1, 2, 3, 4. And the 615 is the lowest. 68, 87, and then there will be 787, 820, and 825, 75. Alright, 12 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wait, they missed one. Oh, 647. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, good. We have that. Now, the 36th percentile. That means everything below or equal to that. There'll be 36% of the data equal or below it. Right? So that 16 of them. And the 36% that will be 36% of the data equal or below it. So we take 30.36 times 16. That's about 5.76. So 1, 2, 3, 4, 5, and 6. So and take that number. Everything equal or below that will be 36% of data equal or below that. So that's going to be that number. Right. Next, the phone data they use in bushel of hay from the farmers the last 10 years. Find the interquartile range. So for this we have to rank them, find the quartiles and the difference of the quartiles. So I'll rank them in increasing order. 150, 180, 147 actually, it's the lowest. And 210. Next, 320, 375. And then in the 400s, 407, 429. And 580. There are 10 of them. So first we find the median, and then the median of the upper half, the median of the lower half to be the third quartile, the first quartile. Right. So there are 10 of them. 1, 2, 3, 4, 5. So the median will be right in the middle here. So it have to be the average of those two numbers. $265. And then we have, of course, the first half, the lower half, and the upper half. The average of the middle of each one. So this will be the first, the third quartile. This will be the first quartile. The one in the middle, the median of the lower half and the upper half. And the interquartile range will be the third quartile minus the first quartile. So 47 minus 180, 227. So that is interquartile range. Right, next, the following, need to timestamp. Next, the following is the sample of 19 November utility bills in dollars from a neighborhood, so that's what we have, those numbers. Luckily it's in the increasing order already, so we don't have to rank them again. Next, the question asks, what is the largest bill in the sample that could not be considered outliers? So first we see if there's any outliers, any values that we say if it's outside of that is outlier, inside will be not outliers. So we need to find those. And to find those, first we find the interquartile range and find the lower fence and upper fence. Alright, first the median 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because actually this one. So there's 19 of them, so the 10 one will be right in the middle. One, 2, 3, 4, 5, 6, 7, 8, 9. So 9 above and 9 below. The 10 is right in the middle, so that is the median. And for upper half and lower half, we find the median of those. The 9 above and 9 below. So for 9, we take the fifth one because there will be 4 above it and 4 below it. So this is the third quartile. And first quartile is 1, 2, 3, 4, 5. Right, and after that we find the interquartile range. Third quartile minus the first quartile. That gives us 14. Right, so we find the interquartile range. After that, the fences. The upper fence is from the third quartile. We add 1.5 of the interquartile range. So the 86 plus 1.5 times 14. So that's 107. And the lower fence will be from the first quartile, counting down 1.5 interquartile range. We don't really need to find a lower fence here. But if we do, we take the first quartile, subtract 1.5 times the interquartile range of 14. So is 51. Or anything between 51 and 107 considered not to be outliers. The 110 outside of this, so that 110 is an outlier. The question asks us, what is the biggest number that not be considered as outlier? So that would be 96. But that's the biggest one that is within the fences.